In this lesson, we will learn about graphing linear functions. How to graph linear functions. Graphs can help you quickly see the relationship between two sets of data, such as the price of milk and the total cost of milk for your family. So basically, graphs are used to see the relationships between two sets of data. Different types of data are graphed differently. Discrete data are data that involve a count of items, such as numbers of people or cars. So what is discrete data? Any data which involves counting of items, such data is called discrete data. For discrete data, plot the data points and connect them with a dashed line. So how would you graph a discrete data? Plot the points on the graph and connect the points with a dashed line. And what is discrete data? It is the data which involves counting of items such as numbers of people, cars, etc. Continuous data are data where numbers between any two data values have meaning. Examples of continuous data include measurements of height, length, or weight. So such type of data such as height, length, or weight, they are continuous data because between any two heights there is meaning. For example, the height can be 5.8 centimeters, 6 centimeters, 6.1 centimeter. It can be continuous. Use a solid line to indicate continuous data. So how do you graph continuous data? You will mark the points and connect the points with a solid line. Graphing discrete data. Let's do a problem where we have to graph discrete data. A gallon of milk costs $2.59. The total cost of G gallons of milk is a function of the price of 1 gallon. The total cost G gallons depends upon how many gallons of milk you buy. Make a table and graph the function. So each gallon costs how much? $2.59. So let's see how we graph this function. Determine whether the data are discrete or continuous. You cannot buy part of a gallon container. You have to buy whole gallons, either 1 gallon or 2 gallons or 3 gallons. So the data are discrete. Make a table. Connect the points with the dashed line. So let's make a table. Number of gallons over here and the total cost over here. 1 gallon costs $2.59. 2 gallons will cost 2.59 times 2. 2.59 times 2. $5.18. 3 gallons will cost $7.77. 2.59 times 3. 4 gallons will cost $10.36 because 2.59 times 4. So we have plotted the information on the table in the form of a table. Now let's draw the graph of this. Let's put the number of gallons on the x-axis, the number of gallons, and the total cost in dollars on the y-axis. This graph is about the cost of milk. So for 1 gallon, the cost is $2.59. That's the point. For 2 gallons, 5.98, approximately over here, and so on. Because the data is discrete, how will we connect the points? With a dotted line. You see the dotted line over there. So this is how you would graph the cost of a milk related in this problem. Graphing continuous data. Let's see how to graph continuous data. During 1 hour of walking, you burn about 257 calories. So every hour, how many calories do you burn? 257 calories. The total number of calories burned is a function of the number of hours walked. So depending upon the number of hours you walk, you burn as much calories as the number of hours you walk. Make a table and graph the function. So what type of data is it? Is it discrete or continuous? You can walk for part of an hour. You can walk for 30 minutes. You can walk for 10 minutes. You can walk for only 5 minutes. So the data are continuous. Plot the data and connect the data points with a solid line. Let's plot the data. The time in this column and the number of calories burned in this column. So for 1 hour, you are burning 257 calories. So for 1 hour, you burn 257 calories. For 2 hours, you burn 257 times 2, which is 514 calories. For 3 hours, you burn 257 times 3, which is 771 calories. So we plotted the information in the form of a table. Now let's draw a graph based upon this table. Plot the time on the x-axis and plot the number of calories on the y-axis. For 1 hour, you burn 257, a little below than 300. For 2 hours, you burn 514, a little less than 550. For 3 hours, you burn 771. If this is 600, this is 700, a little more than 700. So we plotted the points. And how will you join these points? With a solid line. Why? Because the data is continuous. Let us understand what do we mean by y-intercept. The y-intercept is the point where the graph crosses the y-axis. Look at this line on this graph. This line is crossing the y-axis at this point. What is this point? It is y. It is 5. So the y-intercept of this graph is 5. So what do we mean by y-intercept? Y-intercept is the point where the graph crosses the y-axis. Okay, if the graph crosses the y-axis, what is the value of x at y-intercept? It's going to be 0. And in this graph, what is the y value? 5. So the y-intercept as a point can be written as 0, 5. Always remember, in y-intercept, the value of x is always 0 because the point lies on the y-axis. We learned about slopes in the previous lesson. We know that slope is rise over run, and rise is nothing but the vertical change and run is the horizontal change. Let's try to understand how we use the slope in the equation of a line. An equation written in the form y equals mx plus b is said to be in slope-intercept form. So whenever an equation is written as y is equal to mx plus b, it is in slope-intercept form. What does m stand for? It stands for the slope. And we know that slope is rise over run. What does B stand for? It stands for the y-intercept, which we learned recently. And what is y-intercept? It is the point on the y-axis. When the graph crosses the y-axis, that point is called the y-intercept. And at y-intercept, what will be the value of x? It's going to be 0. So let's use this form, which is called slope-intercept form, in graphing the line. Let's look at this now. Y is equal to negative 3 over 4x plus 5. Is this equation now in slope-intercept form? Y is equal to mx plus b. Y is equal to mx plus b. What is the slope over here? It's negative 3 over 4. What is the slope over here? It's negative 3 over 4. And what is the y-intercept? 5. So let's try to graph this line. First, mark the y-intercept. How much is it? 5. So on the y-axis, you mark the point 5 over here. And from there, mark the slope. What is the slope? It is negative 3 over 4. And this is rise. And this is run. So since the slope is negative, from the y-intercept, you go down 3. 1, 2, 3. And then run towards the right 4 units. 1, 2, 3, 4. You land up at this point. So join the 2 points and you get the line of this equation. A linear function is a function with points that lie on a line. So if you have points which lie on a straight line, that type of a function is called a linear function. You can write a linear function in the form f of x equals mx plus b or y equals mx plus b. You can write any linear function in the form y equals mx plus b or f of x equals mx plus b. Then you can use the slope and y-intercept to graph the function. Remember, we learned that y is equal to mx plus b. What is this form called? It's called slope-intercept form. Slope-intercept form. And what does m stand for? It stands for slope. And slope is nothing but rise over run. And what does b stand for? It stands for the y-intercept. And what is y-intercept? The point on the y-axis. So we can use the linear equation y equal to mx plus b and graph the line. And we will see how to do it. Graph the function y is equal to 3 over 5x plus 1. So let's look at this equation. Y is equal to 3 over 5x plus 1. The question is this in the form y is equal to mx plus b? Y is equal to mx plus b. What is m over here? 3 over 5. And what is b over here? Plus 1. So the slope is how much? 3 over 5. That means the rise is 3 and the run is 5. And what is the y-intercept? The y-intercept is, let me write down neatly, the y-intercept, y-intercept is 1. That means on the y-axis we are going to mark 1. And from there we are going to rise 3 and run 5. Let's see how we graph this point. Look at this. Look at this graph. First thing, what is the y-intercept? 1. So on the y-axis, mark the point 1. From there, how much is the slope? 3 over 5. The rise is 3. The rise is 3 and the run is 5. So from 1, the y-intercept, rise 3 units. 1, 2, 3. And from there, run 5 units. 1, 2, 3, 4, 5. And we'll end up here. So you can join these 2 points. And if you want to draw another point, from this point, rise 3 again. 1, 2, 3. And run 5 again. 1, 2, 3, 4, 5. You land up at another point and join those 2 points. So you can draw a straight line. So the graph of this equation, is this straight line, what you see over here. So from the slope-intercept form, you can easily graph an equation. So you have learned how to graph equations which are in slope-intercept form. You have also learned how to differentiate between discrete data and continuous data. That is what the lesson was about.